Okay, let's just start. We're going to talk about compositional functions. I'm just going to start with two functions with familiar tables. There's your toolkit exponential function, y equals 2 to the x. And I'm going to make a table for this function, but I'm not going to. So this is getting crowded here, but it's y equals g of x equals 2 to the x. Here's your table. And we're going to let f of x equal x squared. Now we could make a table for x squared, but it's not going to be all that helpful in what we have to do. So what we want to do is we want to for each x, we want to put the value of g of x into the f of x function. So let me just ask him, and you can tell me, I can give you a minute to think about it and process the question. Okay, for each x, we're going to put the value of g of x into the f of x function, right? So I give you if x equals -1, what number goes into f of x? Okay, well, I've got a perfect good answer written out in good form. But, just looking at this, just for the sake of anybody who's just kind of looking at it, excuse me, just a minute, I don't know what's going on with this camera, but it seems to be aimed too high. So we're not getting the bottom of the board, which is not a good thing at all. Like something is changed the camera, it's crooked. I'm going to pause for a second, just fix this a little better. Okay, moving a little further along, maybe change the angle of the board to match the angle of the camera. And then trying to figure out what I just did with the white chalk. This is getting ridiculous. Let's set it down over here. Gonna pause. Okay, excuse the interruptions. I still don't know what's going on with the camera. Okay, so the question was, if x equals -1, what number goes into f of x? And I said for each x, you put the value of g of x into the f of x function. Well, then if x is -1, that's your x. What's the value of g of x? You can read it off the table. If x is -1, g of x is 1/2. Okay. So if x equals -1, g of x is 1/2. So 1/2 is what goes into f of x. So f of 1/2, since f of x equals x squared, f of 1/2 is 1/2 squared, which is 1/4. Okay. Okay, if we're putting the value of g of x into the f function, that means we have the function f applied to whatever g of x is. What's h of 1, -1, equals f of g of -1. G of -1 is 1/2, and f of 1/2 is 1/2 squared, which is 1/4. Make sense? So here's another kind of a schematic. Goes into g of x, which gives you half, which goes into f of x, which gives you 1/4. Does that make sense? -1 is the input for g of x. The output of g of x is 1/2, and that's the input for f of x, and you end up with 1/4. Okay? So that's one way to look at composition. You're just feeding the value of one function into another. Now we could do this in symbols. If h of x equals f of g of x, well, that means h of x is f of 2 to the x, because g of x is 2 to the x. Okay? And what's f of 2 to the x? Well, you're replacing x by 2 to the x, right? And that equals 2 to the x squared. Because what f does to whatever you put into it is it squares it, right? So the g of x function outputs just plain old 2 to the x. If you input that into the f of x function, f of x squares it. F of x is the squaring function. Okay? And if you understand function notation as substitution, which you should in the problems that we did, for the first few weeks, and which everybody here seems to understand because you seem to be using function notation pretty well. There's our result. Okay, let me give you one to do. So again, we'll say h of x equals f of g of x. Where f of x equals 2 to the x. And g of x equals 1 over x. Just your toolkit exponential function, toolkit reciprocal function, but we're combining them in a new way. See if you can write out what h of x equals. As many steps as you can complete. Okay, now this often gives people quite a bit of trouble because you want to think about what it means or what you're going to do with it or anything. And it's nothing like that. It's just a clerical procedure. So first of all, you want to write down exactly what I've written down here. And then we say h of x equals, I had 3 dots, but I've erased those dots because I want to fill in what h of x equals. Okay. So what is h of x? Well, first of all, it's f of g of x. And I'm just repeating what I said up here. So we're on perfectly solid ground writing f of g of x. Now, what are we going to do? Well, we actually have 2 alternatives. But if we follow the idea here that we figure out what g of x is and then put it into the f of x function, we're going to replace g of x by its formula, okay? So we're going to get f of 1 over x, since g of x equals 1 over x, okay? Now, what's f of 1 over x? Well, you go back to the definition of f of x, which is 2 to the x. So what we're going to do is we're going to replace x by whatever's in here. X is going to get replaced by 1 over x, right? And if this x gets replaced by 1 over x, oops, I circled the wrong one. It's f of 1 over x. So x is being replaced by 1 over x. So this x is going to get replaced by 1 over x. Okay? So we say f of 1 over x is equal to what we get when we replace this x by 1 over x, which is 2 to the 1 over x. Now that's hard to get used to, so let's do a couple more examples. Just with the notation now. I use this side of the board on it. Okay, I'll keep h of x. See if you can give me an h of x equals here. Okay. Okay, very good. And we'd spend a little while on that, but it's well worth it because this is a big deal. This is one of the ways you put functions together. My multivariable calculus class this afternoon is going to figure out for a function that has like f of x, y, z, three variables, big old ugly function, okay? They're going to be figuring out the formula for the rate of change of that if x is a function of something else and g is a function. All these things are composites. It's called the chain rule, okay? It's a big deal. It's a big deal. Now, they're pretty well prepared to do it because they've done well in first year calculus, but it's still going to blow their minds. Okay, I'm looking forward to it. Okay, h of x is what? Well, first of all, let's write out what h of x is. It's f of g of x. Of course, it's written up here, but I don't want to see it. I don't have to look back up here to see what I'm doing. I start out with the simplest thing I can write. H of x equals f of g of x. Then what do? Well, g of x is x squared. So I just replace g of x with its formula. G of x equals x squared, so f of g of x equals f of x squared. Now, we're done with the g functions. We don't keep looking back at g. We've already done what we need to do with g. We focus on f. And this worked out. This worked out. Okay, what does f do? Well, f of x is x over 1 plus x. So f of x squared is x squared over 1 plus x squared. In other words, we replace x by x squared. So we replace each of these x's by x squared. In writing f of x squared, I have replaced x by x squared. So I got to continue to do that. It's going to give me x squared over 1 plus x squared. And everybody got that? That's good. Okay. Now, I want to take 5 minutes and start talking about transformations. F of x equal, let f of x equal x squared. And what's f of x minus 6? You're going to get it. I'm going to write it down for you. Why don't you think about it for a second? It's x minus 6 squared, right? Whatever goes in here replaces x, and this x has to be replaced by the same thing. Okay. Now we know the graph of f of x is fairly easy to construct. And I'm using standard type 1 grid. To draw fairly decent function. It's lopsided. It's hard to do it right. And you got to kind of block the board to do it, and I don't want to block the board, so my excuse. Don't do it all that well, even if I'm not blocking it. Yeah, I am blocking the board. Okay, so here is f of x. Here's x equals -2. Here's x equals 2. Here's y equals 0. Y equals 4. And everybody should be familiar with this. Okay. Now, let's take x and x minus 6 quantity squared. What number would you put in for x if you wanted to get 0? Well, actually, let's go ahead and just write down the x squared. Values 4, 1, 1/4, 0, 1/4, 1/4. Okay. if I put in 0 for x on the x minus 6 function, I get 0 minus 6 squared, which is minus 6 squared, which is 36. I want to get 0. Okay. What number would I have to put in for x to get 0? Show me with your fingers. What number minus 6 gives me 0? Yeah, 6. It's obvious, right? Okay. So I'm going to put 6 over here across from, kind of the same line where I've got 0, and I'm going to get 0. Okay. Now, I want to get 4 here. What number could I put in to get 4? Well, I'm not going to make you think because we're real short on time, but look, here I am at 0, which gives me 0 when I do x squared. It's 6 that gives me 0 when I do x minus 6 squared. Okay. If I move from 0 to negative 2, I'm going to get 4, right? That's just like moving from 6 to 4. Okay. Another way of looking at it is, how do I get 6 from 0? I add 6 to 0, right? I add 6 to negative 2 and I get 4. And you can check if I plug in 4 here, I get 4 minus 6, which is negative 2. Square that, I get 4, just like I said I would. Okay. If I add 6 to negative 1, I get 5. Plug in 5 here, and I get 1. If I add 6 to negative 1/2, I get, we can call it 5.5, and I get 1/4. And so on. This means that my graph of x minus 6 squared lies 6 units to the right of my graph of y equals x squared. And here's my y equals x squared graph. And then, let's see, 2's here. I'll go 4 to the right of that, I get 6. So over here, I get x equals 6. And at x equals 6, I get y equals 0. Well, then I can move 2 units to the left of 6 and 2 units to the right. I get x equals 4. And 2 units to the right, I get x equals 8. And it's going to turn out that my graph is here. And every point is moved 4 to 6 units to the right. Okay. This point moves 6 units to the right. This point moves 6 units to the right. This point moves 6 units to the right. Every point moves 6 units to the right, which means that if I replace x by x minus 6, whatever graph I'm doing, turns out the number is going to move 6 units, the graph is going to move 6 units to the right. Okay, so I can say that f of x minus h moves each point of f of x by h units horizontally. We'll go on with this idea next time, but give it some thought, because this is the idea that confuses people most when we do transformations.